students, I hope you're able to hear me. Let's get started. So yesterday we did till 19th problem, right? We finished it. 19th problem, the limit was 0. Now let's do the 20th one. Okay. So the formula to be recollected, limit extends to 0, sin x by x is 1. Limit extends to 0, sin ax by x is a. We know why it is so, because here it is ax, we need to divide it with a and multiply back with a so that you get the final answer also as a. So limit extends to 0, you have sin ax plus bx divided by ax plus sin bx. How to proceed this? Where a comma b and a plus b is not equal to 0. This is a condition. So I can write it as limit extends to 0. So what we will do is divide the numerator and denominator with ax or with x alone. Okay, sin ax. Then what I will do here is plus bx divided by, I'll put ax into ax divided by ax plus, tell me what am I supposed to divide the denominator with?
Bx.
So with bx and compensate it with bx. Here x and x will get cancelled, which implies limit extends to 0. Okay, sin ax divided by ax plus limit extends to 0 bx divided by ax into a. Did you guys understand what I did? I multiplied this a with each term, okay, and I wrote it as a separate term. The whole divided by what will happen, the denominator, limit extends to 0, ax divided by bx into b plus sin bx divided by bx into b. Here also you have limit extends to 0. Now x and x will get cancelled here. Here also x and x will get cancelled. B and b are gone. A and a are gone. So what is that you will get in the numerator? So limit extends to 0, sin x by x into a. That is, what is it, guys? What is it? See, if there is a doubt, ask, or else tell me. So when I substitute the value here, sin ax by ax with the limit extends to 0 is going to be 1. 1 into a plus limit extends to 0. B by a is b limit extends to 0. B, the whole divided by limit extends to 0 a plus what will happen here? That will be a plus b divided by a plus b. Answer will be 1. Am I audible? Am I audible or not?
Yes, sir.
So a plus b divided by a plus b is going to give you a 1. So this is the final answer. Next.
1 minute.
Yeah, right.
Done, sir.
So limit extends to 0 cosecant x minus cot x. So cosecant x can be written as 1 by sin x minus cot x can be written as cos x divided by sin x. So if you substitute the limit, what will happen is you will get infinity minus infinity, which is not valid. So what we are supposed to do is, first we need to simplify it. Limit extends to 0. It will be 1 minus cos x divided by sin x. That is limit extends to 0. What is 1 minus cos x? 2
Sin x.
2 sin square x divided by 2 divided by, how can you write sin x in terms of sin x by 2 and cos x by 2? So we know
Sin
that
x in terms of
sin 2x is 2 sin x cos x, right? So if it is sin 2x here, then it will become 2 sin x into cos x, that is half of the original angle. So if it is sin x, then how can we write? So if it is x here, then what will happen to the angles here and here?
x by 2, sir. X by 2.
That's right. That's right. Sin x by 2 into cos x by 2. Okay. Since 1 minus cos x is 2 sin square x by 2 and sin x is 2 sin x by 2 cos x by 2. Okay. Now, what will get cancelled? 2 and 2 are gone. 1 sin x by 2 gets cancelled. Now, what is that you're left out with? Limit extends to 0. Sin x by 2 divided by cos x by 2. What is the answer? Limit extends to 0. Tan x by 2. So, when you substitute limit, you will get tan 0, which is 0. So, limit extends to 0. Cosecant x minus cot x is 0. Okay. Next. So limit extends to pi by 2, tan 2x into x minus pi by 2. Mark it as important. So I'm going to solve this problem using substitution method. So what I'm going to do is, when x is tending to pi by 2, okay, then can I say x minus pi by 2 tends to 0?
Sir.
That is what I did is, I treated it like equal to, I brought pi by 2 to the left hand side, x minus pi by 2 tends to 0. The reason why I'm doing this because I have x minus pi by 2 here. So what I'm going to do, put x minus pi by 2 as y, which implies when x is tending to pi by 2, y tends to what?
Tends to 0, sir.
Y tends to 0. It's very simple. What you can do is, x tends to pi by 2 means, substitute it here. Pi by 2 minus pi by 2 is 0. So when x is tending to pi by 2, y is tending to 0. So limit of, in the place of x tends to pi by 2, I can replace it with y tends to 0. Clear? Tan 2 of, in the place of x, I need to replace it with y. What is x equal to? Y plus pi by 2 divided by, in the place of x minus pi by 2, I can write it as y. Right? So limit y tends to 0. Tan 2y plus pi divided by y. Tell me, is there any doubt till this step, guys?
No, sir.
Okay. So limit y tends to 0, what is tan pi plus theta? Tan of pi plus theta. So pi plus theta, where theta is acute, means which quadrant
It's
are we
theta,
going?
sir. Quadrant.
We are going to third quadrant. Third quadrant, tan is positive. So answer will be tan 2y divided by y. Yesterday I told you an important relation. Limit y, x tends to 0. Tan x by x is also equal to 1. It is similar to sine. So in the place of tan, had we had sine, what do we do? Since here we have 2y, what will you do?
Into 2.
Divide with 2 and multiply with 2, right? Now when you substitute the limit, what will happen? You will have 1 into 2. Why 1 into 2? Because limit y tends to 0, tan 2y by 2y is 1. 1 into 2 is going to give you. So this is the final answer. Am I clear, guys?
Yes, sir.
So I suggest you all to practice it again. Okay. Next. See, going forward, right? Problems will be slightly tough. You need to have a clear understanding. If there is any doubt, immediately ask and get it clarified. Don't wait till you sit and practice, and all those things will never happen. If you have doubt, get it clarified.
Okay, sir.
So find limit extends to 0 f of x and limit extends to 1 f of x, where the function is actually split at which point? It is split at x is equal to 0. Okay. So what we are supposed to do here is limit at x is equal to 0. Look at the way I'm going to handle it. So limit extends to 0 f of x. See, unlike the previous problems, we cannot directly solve this problem because in the previous problem, limit extends to 0 f of x means you had only one function. For example, it was sin x, it was only sin x. If it was sin x by x, it was only sin x by x. Whereas here, what is happening? On the left of 0, that is 0 here, less than 0, greater than 0. At x is equal to 0 and less than 0, the function is 2x plus 3. At right side of x greater than, at right side of x, it is 3 into x plus 1. Are you guys able to understand? So first what we need to do is, we need to verify the left limit of it. So when I take left limit, so I write it like this, limit extends to 0 minus. Look at the way I'm going to write. Limit extends to 0 minus f of x is equal to, what is the formula that I gave you? Limit extends to 0, f of x naught minus h, where x naught is what? 0. Does it make sense? Are you able to understand what I wrote?
This is
So
at 0, sir. When
this
x
is
is
on
equal
the
to
left of 0. This is at left of 0.
Okay, sir.
So here I wrote no 0 minus. Okay. So there is a difference. If I put a 0 and I put a minus here, then I'll put a h here. If I just put a 0 with a minus on the top, like how you write for ions, okay, 0 with a minus on the top, then it is called as left limit of 0. For example, if I write 1 with a minus sign on top, it is left limit of 1. Okay, that is just a symbol. So limit h tends to 0, f of 0 minus h. So limit h tends to 0. In the place of f of 0, in the place of x for the function, I need to substitute 0 minus h. Out of 2x plus 3 and 3x plus 1, which one should I choose in this case? So what is the function that is defined on left of 0?
2x plus 3.
It is 2x plus 3. Limit h tends to 0. 2 into, in the place of x, I need to substitute 0 minus h. 0 minus h plus 3. Now I can directly substitute the limit because it's a simple function. So 2 into 0 is 0. Answer will come out as 3. Am I clear with this? Is there any doubt, guys?
So I have a doubt.
Yeah, get it clarified.
If 0 minus h, shouldn't it be minus h, sir?
Sorry. It is minus h only, but when you substitute h is equal to 0, whether it is minus 0 or plus 0, it doesn't make.
Okay, so we are substituting. Okay, yes, sir. Understood now.
That's why I
Sorry,
put that
sir.
arrow mark.
Yes, sir. Understood. Sorry,
Okay.
sir.
So going forward, if I put an arrow mark, it means I'm substituting. No problem. No problem. Okay. So similarly, when I check for right limit, how should I write? You guys tell me. Limit x tends to 0. What should I put on the top?
Plus
0 plus the function is equal to limit. So instead of x, I should replace it with h. H tends to 0. F of what?
x naught plus h.
Here x naught is how much? X naught is the point where you're checking the limit. At which point are you checking the limit?
At 0.
So you have to write it as
0
0 plus h. Okay. Now limit h tends to 0. F of 0 plus h means which one should I use?
3x plus 1.
Yes, 3 into wherever x is there, you have to substitute 0 plus h and you have a plus 1. That plus 1 is also inside the bracket. Be careful with that. Okay. Now I'm directly substituting the limit. So when I substitute the limit, I'll get 3 into 0 plus 0 plus 1. What is the answer? It is 3. So left limit is also 3, right limit is also 3. What is the function value? What is f of 0? So for f of 0, out of the two functions, which one should I choose? Which function is
2x
defined?
plus 3, sir.
Yes, it is 2x plus 3 because you have less than or equal to, no? So f of 0 is 2 into 0 plus 3, that will be 3. So what is happening here? Left limit is equal to right limit is equal to the function value. So this function is having its limit existing at x is equal to 0. Am I clear? So that
Yes,
is what
sir.
they mean by asking find the limit at x is equal to 0. Make a note of this. There's a very good, I will not say very good, but I suggest you all to practice it again.
Sir, doubt, sir. So now
Yeah,
we are
tell me.
doing the same thing with x tending to 1 instead.
Extending to 1, you have to do the same thing,
X
but
naught will be 1.
yes, x naught will be 1. But I want to tell you an important point. Do we need to do all this process for extending to 1? Think about it. I'll tell you the answer also. You need not do. Why you need not do, you people think. Why did I do it only at 0?
Because eventually h will tend to 0, sir. It will be 1.
No, that's not the reason. That's not the reason. It has nothing to do with the limits and all. It's a simple logic. You look at the function, you'll understand. The function is broken into two parts, right? The function is broken into two parts. One part is 2x plus 3, and the other part is 3 into x
Both
plus
will
1.
be equal, sir.
No,
If you
no, no.
subs-
No, wait. Where is it broken? At which point is this breakage taking place? Look for the domain, no? At which point is the function broken into two parts? At which point, man? X is equal to how much? At what value of x naught is it broken into two parts?
At positive, sir.
At 0. So the function is actually broken into two values. At x is equal to 0, at x less than 0, you have a function. At x greater than 0, you have another function. Whereas at x is equal to 1, how many functions will you have? So look at both the functions, no. So x is equal to 1 means, is that value greater than 0 or less than 0?
Greater than 0, sir.
So greater than 0, how many functions do you have?
Only one.
It is only one. So when they ask you limit x tends to an f of x, take that one and substitute it in the second function, you will get the answer. So here the logic is you need to do the left limit and right limit only if the function is split into different parts. Split into different parts means this is the point where the splitting is taking place. Let me actually show you what is the meaning of this, okay? So can you tell me the functions? It is 2x plus 3 when x is less than or equal to 0, 3 into x plus 1 when x is greater than 0, right? So there is nothing but f of x. So I told you in functions chapter itself, wherever f of x is there, it is y. Now see. X, y, x dash, y dash. So y is equal to 2x plus 3. Am I right? So y is equal to x plus 3 represents what? Y is equal to mx plus c. It's a straight line with the slope as 2. So this will be the line. Am I clear?
Yes, sir.
Okay. So this is the graph for what? Y is equal to 2x plus 3. At x is equal to 0, when you put x is equal to 0, this value comes out to be 0, 3. Okay. Similarly, if I ask you to draw the graph for y is equal to 3 into x plus 1, what is the meaning of it? So y is equal to 3 into x plus 1 is y is equal to 3x plus 3.
Yes, sir.
So y is equal to 3x plus 3 is a graph like this. Okay. So what is happening is when you're coming, so there is the point 0, 0, 0. So there is the point where x is 0, 0, 3. That is when you're approaching towards x is equal to 0 from left hand side, you're traveling through this function. And where is this function heading towards? What value of y is it heading towards? It's heading towards a value of 3. Whereas the first function is exactly having a value of 3. And when it is greater than 0, when 2x plus 3 is greater than 0, when you approach from the right hand side, it is heading towards the same point 3. So the left arrow mark which I draw is going to give you the left limit. The right arrow mark which I drew will give you the right limit. And this red color dot will give you the function value. All the three are actually meeting at the same point. That is why we are able to say that this function is continuous. Are you able to visualize it?
Yes, sir.
Okay. So, but this year they will not use the word function is continuous. They will use the word limit exists. Next year you will have this same concept. So when they ask you, what do they actually mean by asking you limit exists? They are trying to say that the limit exists at that point means the function is continuous at that point. Means when you approach from left hand side, you're going towards a y value of 3. At exactly 0, you're having a y value of 3. On the right of it, you're actually starting from y is equal to 3. So there is no break anywhere. Whereas sometimes what will happen is, for example, if I change the question like this, if the question was given like this, y is equal to 2x plus 3 and y is equal to 3x plus 2. This is for x less than or equal to 0. This is x greater than 0. Okay. Now if I try to draw the graph, understand. If I try to plot the graph, what is going to happen? Sorry. This is x, y, x dash y dash. So y is equal to 2x plus 3. By now you know. Where does it start from?
Starts in 3, sir.
0, 3. So this is y is equal to x plus 3. Whereas if I draw for y is equal to 3x plus 2, what will happen? Are you clear? So y is equal to 3x plus 2 because when I put x is equal to 0, what is the value of y I'm getting? 0, 2. Means y is equal to 3x plus 2 when you're trying to approach from left hand side is approaching towards a y value of 2. Whereas y is equal to x plus 3 when you're approaching towards x from, when you're approaching towards 0 from right hand side, it is approaching a y value of 3. Are these two graphs meeting?
No, sir.
So this is the meaning of discontinuity. That is what you mean by left limit and right limit. Okay, even if you're not able to understand this, it will take some time because you people need to master function. Your CBSE content is actually not enough for functions, but if you practice more, you can get it. But are you able to understand what I'm saying?
Yes,
I'm not
sir.
saying you need not do all these things. I'm just trying to explain the inner meaning of it. Okay, this is what happens. This is the meaning of limit existing. So you need to do now. Did you get clarity of when you need to do the left limit and right limit? It is at the point where it is broken, wherever you're splitting the function. Whatever is the value of x at which you're trying to split the function into different parts, it is not necessary it has to be split only into 2 parts. It can be split into 10 parts also. It's up to us. But 10 parts cannot happen at the same point. At one point, you can only split it into 2 ways. Okay. So with respect to this question, if you see, it is split only at which point? Only at x is equal to 0. Whereas at x is equal to 1. At x is equal to 1. Where is x is equal to 1? See, this is the point where x is equal to 1. At x is equal to 1, if you see, are you able to see that this graph is continuous already? It doesn't have any break because it's a straight line.
Yes, sir.
So at x is equal to 1, what do we need to do? You need not check the left limit or right limit because whether you approach from left hand side or right hand side, where is the value heading towards? It is a continuous graph. It is exactly heading towards the function value. So limit extends to 1. Which function should I take into consideration? Look at the graph, you'll get the answer.
2x plus 3.
2x plus 3. So I will directly write f of x. I'm not writing 1 minus and 1 plus. So what will the answer be?
5, sir.
That is the meaning. That's it. So that's the value of limit extends to 1 f of x.
Sir, could you show the screen again, sir?
Tell me.
Can you go up, sir?
Yeah. Sure.
A bit more up, sir, the question. So you told that if x is greater than 0, no, sir, here when x tends to 1. So we should take 3x plus 1, no, sir? 3 into x plus 1.
Oh, I drew the graph itself in reverse. I'm sorry, guys. Actually, the graph which I drew is like this. Okay. Graph I drew only to explain you guys. X greater than or equal to 0. Okay. But according to this question, yes, what you told is right. It should be 3x plus 3. So don't get confused between the graph and this part. So answer should be 6.
Okay, sir.
Okay. Shall I move on?
Yes, sir.
No, see. So limit extends to 1 f of x where f of x is x square minus 1 and minus x square minus 1 for x less than or equal to 1 greater than 1. So what is the value at which we need to check the limit? So it is 1. At that 1, what is happening? The function is broken into 2 parts. So what are we supposed to do? Take the left limit. So left limit is limit x tends to 1 minus f of x is equal to limit h tends to 0 f of 1 minus h. That is x naught minus h, where x naught is 1. So when I do 1 minus h, what am I supposed to do? Limit h tends to 0. Wherever x is there, I will substitute 1 minus h. So this will be equal to limit h tends to 0. 1 minus h the whole square is 1 plus h square minus 2h minus 1. So 1 and 1 will get cancelled. Now when you substitute h tends to 0, the answer will be 0. Is that clear? Similarly, right limit, you guys tell me. Limit x tends to 1 plus f of x will be equal to limit h tends to 0 f of
1 plus
what? 1 plus h. So limit h tends to 0, 1 plus h means minus of 1 plus h the whole square plus 1. So limit h tends to 0, minus of 1 plus h square plus 2h plus 1. So 1 and 1 will be gone, answer will be 0. So left limit is 0, right limit is 0. What about the function value? F of 1. So f of 1 means out of both the functions, which one should I take?
x square minus 1.
Yes. So 1 square minus 1, answer will be 0. So left limit is equal to right limit is equal to the function value. Hence, the limit at x is equal to 1 is 0. So the answer is 0. So I'm moving on. Okay. So limit x tends to 0 f of x, where f of x is equal to mod x by x. Okay. So remember, mod x by x is also defined like this. See, if I give you f of x is equal to mod x, I ask you to define it. How is it defined as? Then f of x will be equal to x when x is greater than 0, 0 when x is equal to 0, minus x when x is less than 0. Accepted?
Yes, sir.
So here if you see, the function is mod x by x when x is not equal to 0 means this case is eliminated. So look at the way f of x is equal to mod x divided by x. Look at the way I'm going to define. So mod x is positive and denominator is x only. So when can I write mod x as x? When
X is greater than 0.
So mod x by x is nothing but 1. Correct? Similarly, minus x by x when x is less than 0, because when x is less than 0, mod x will be minus x. What is the answer for this?
Minus 1, sir.
Minus 1. And it is 0 at x is equal to 0.
Sir, we shouldn't write 0, no, sir, since x is
No need,
not
do you
equal
not-
to 0.
X is not equal to 0. You should not write because they themselves have given what is happening at x is equal to 0. If you observe this, this is nothing but signum function. If you revisit functions, you can see this kind of a function which is called as signum function. Okay. So limit x tends to, sorry. So I'll write the function clearly. F of x is equal to 1 when x is greater than, I'll actually come from x less than 0, is equal to minus 1 when x is less than 0, 1
Sir,
when
right,
x is
sir.
greater. Am I clear, guys?
Yes, sir.
Now tell me, what is limit x tends to 0 minus?
F of x will be minus 1, sir.
That's right. Limit h tends to 0, f of 0 minus h. They're asking us at 0 only, no? Yeah, 0 minus h. So limit h tends to 0. Here there is no x at all. So I will directly write minus 1. So limit of something tends to 0, a constant value is nothing but the constant only, minus 1. Similarly, what do you think we will get for limit x tends to 0 plus? Limit x tends to, sorry, h tends to 0, f of 0 plus h. That will be limit h tends to 0,
1 plus
0, 1. Answer will be 1. So what is f of 0?
0, sir.
That's right. So left limit is minus 1, right limit is 1, and the function value is 0. So the answer to this is limit does not exist. What is given at the back? Can you check the answer and tell me?
Given it does not exist at 0, sir.
That's right. Limit does not exist. Now I hope you guys understood what is the meaning of limit does not exist. The left limit is not equal to right limit is not equal to function value. The limit does not exist. So to put it in simple terms, it's a discontinuous function. It's a very simple thing, right? I will explain it graphically also, you'll understand it. So when I take it like this, so when x is less than 0, it is minus 1. Minus x, y is equal to minus 1 is a line parallel to x-axis. So it will come till here, it will be open. At x is equal to 0, it is 0. At x is equal to 1, it is like this. Are you able to understand this graph? So this is y is equal to 1, this is y is equal to minus 1, and this is y is equal to 0. So all the 3 points, none of them are meeting. See, wherever they are not meeting, no, you need to put an open circle. That is called as point of discontinuity. That anyways you will learn next year. It's called point of discontinuity. That is a point where the function is discontinuous. That is a meaning.
Here the limit x is at 0, no, sir. Given the question.
It doesn't exist.
I mean x naught value, sir. The x naught value is.
No, that's the case. That's what I'm trying to. When I say limit exists, so limit exists means it is not like you're getting a finite output. See, I'm able to understand why you're thinking like that. See, since f of 0 is coming out as 0, which is a finite number, you think it is existing. No. For you to complete the statement saying that the limit exists, when you calculate the left limit of the function, when you calculate the right limit of the function and the function value, all the 3 should come out as the same output.
So they all should be in the same point.
Same number. So to put it in simple terms, the final value that you're getting should be the same number. Had this value come out as 0, had this value also come out as 0, and function value is 0, then we can say limit exists.
Okay, sir.
Else it does not. So it has nothing to do with whether you're getting finite output or infinite output. Value should be the same. That is the meaning.
So can you show the question once, sir?
Yeah, sure. So this is another definition, other way of defining signum function. If at all you have in your exam, okay, you can understand. If at all you get a question like this, you can understand they have indirectly asked you signum function.
Done, sir.
So same logic, guys. I hope this you can do it. So what are we supposed to do? F of x is equal to x by x when x is greater than 0, because mod x is positive for x greater than 0. X by minus x, which is equal to minus 1 when x is less than 0. 0 at x is equal to 0. So I'm saying, what limit is this? This is right limit. This is left limit. This is f of 0. Are all the values same?
No, sir.
So here also the limit does not exist. So this is also signum function. Only difference is there the mod x was in the numerator, here it is in the denominator. But the story is the same. Okay. So this problem, I'm leaving it to you. There is nothing for me to explain. Now see. Solution. Limit extends to 5. F of x is limit extends to 5 mod x minus 5. Okay. So when I substitute 5 here, what do I get?
0, sir.
That's it.
Or minus.
It's,
It can be even minus 5. No, no.
it will not be minus 5 because mod x is getting split into 3 different values at which point?
When x is at 5, sir.
X is at 0. There is only one definition of mod x. Mod x, when f of
Yes,
x
sir.
is
Understood.
x minus x 0, this all are happening at x equal to 0 only. But
Yes,
you're
sir.
taking a point which is greater than 0. 5 is a point which is greater than 0. When you're taking any point greater than 0, x will be 5. So 5 minus 5. See, mod of something is always positive. 5 minus 5 into 0. Okay. So 28. You can expect these
That's
kind
it,
of.
sir. 27.
That's it. That's it. Nothing else. It's 0. That's it. You need not do any left limit or right limit.
Okay, sir.
So again, if you look at this problem, there is a split that is taking place at which point?
X is at 1, sir.
X is at 1. So they have given limit extends to an f of x is equal to f of 1. This means limit exists. Okay. What are the possible values of a and b? Means what they are trying to say is left limit is equal to right limit is equal to f of 1. So for left limit, what should I do? Limit extends to 1 minus f of x is equal to limit h tends to 0 f of 1 minus h. So what will I get, guys? Limit h tends to 0 f of 1 minus h means which function should I use out of all the three?
A plus bx, sir.
Yes. So a plus b into, in the place of x, I will write 1 minus h. I will take this 0 and substitute it here. I'll get a plus b. Clear? Similarly, if I do right limit, limit x tends to 1 plus f of x is equal to limit h tends to 0 f of 1 plus h. So limit h tends to 0, which function should I use? One plus means greater than 1.
B minus ax, sir.
So b minus a into, in the place of x, I will write 1 plus h. Substituting the limit, I'll get b minus a. Right? F of 1 is how much?
4, sir.
4. So they have told left limit is equal to right limit. So a plus b is 4 and b minus a is also 4. So when I add both, 2b will be equal to 8. So b will be 4. If I take b is equal to 4 and substitute it here, what will be the value of a?
A is 0, sir.
0. So a value is 0, b value is 4. Can you check the answer?
Yes, sir. Correct. Okay.
Yeah. So A is 0, B is 4. Okay. Shall I move on? Shall I go to the next question? No, see. Now the 29th question is, let A1, A2, so on till An be fixed real numbers and define a function f of x is equal to x minus A1 into x minus A2, so on till x minus An. What does limit extends to A1? I think it is f of x, right? Can you check the question and tell me? So limit extends to A1 f of x for some A which is not equal to A1 or A2 or so on till An. Also compute limit extends to A f of x.
Question is correct, sir.
So solution is limit extends to A1 f of x is, take this A1 and substitute it in x minus An. So when you substitute A1 here, what will you get? You will get A1 minus A1 into A1 minus A2, so on till A1 minus An. So A1 minus A1 is going to be 0 into anything is going to be 0. Accepted?
Yes,
Right?
sir.
So that is the value of limit extends to A1. What about limit extends to A f of x? So that will be limit extends to A. F of x will be A minus A1 into, x minus A1, x minus A2, so on till x minus An. Right? Now when you substitute A, you will have A minus A1 into A minus A2 into A minus A3, so on till A minus An. So this is the value of limit extends to A f of x. Just have to substitute that value, that's it. Clear? Third year. If f of x is equal to mod x plus 1 when x is less than 0 is equal to 0 for x is equal to 0, mod of x minus 1, mod x minus 1 when x greater than 0, for what value or values of a does limit extends to a f of x exist? How to do this?
0, no, sir. A 0.
No. See, what happens is generally mod of x plus 1 is there, right? So when x is less, so see, look at the way I'm going to define the function. F of x is equal to, when x is less than 0, what is going to be mod x? Forget about plus 1, all those things. Concentrate only on mod x. When x is less than 0, that is when x value is negative, what does mod x give you?
Give a positive value, sir.
Positive value. You will get that positive value by multiplying the negative value with a negative sign. That is why we write minus x. So that's how we define, no, f of x is equal to mod x. It's x minus x 0. When x greater than 0, x less than 0, and x is equal to 0. Correct?
Yes, sir.
So when x is less than 0, it is minus x. So here also it is minus x plus 1 when x is less than 0. Means what I'm doing is I'm eliminating that mod. 0 when x is equal to 0. Then what will happen? Mod x minus 1 when x is greater than 0. So what is mod x when the value of x is greater than 0?
will be plus x. Yeah.
That's right. So it is x minus 1 when x greater than 0. Now am I clear? So what I did is I split the same function without modulus. But you need to have a clarity of how to eliminate that modulus. So only thing is you need to check for the modulus function when it is less than 0 and greater than 0. So this has to be in your mind, guys. This is coming from the basic functions. I didn't define it. If you go and revisit the second chapter, you can find that this function mod x is defined like this one. Okay. Now I'm going to check limit x tends to 0 minus. What is limit x tends to 0 minus? That is limit h tends to 0, f of 0 minus h. Which function should I take?
Minus x plus 1, sir.
Yes. So limit h tends to 0. In the place of x, I will substitute limit h tends to 0 minus of 0 minus h plus 1. So when I substitute the 0 here, I'll get the answer as 1. Okay. Similarly, limit x tends to 0 plus f of x is equal to limit h tends to 0, f of 0 plus h. What will you get? Again, substituting the limit, you will get as minus 1. So what is f of 0?
0, sir.
F of 0 is 0. So left limit is 1. Right limit is minus 1. Function value is 0. So limit does not exist at x is equal to 0. Correct?
I have a doubt, sir.
Tell me.
Why do we have to find function value if right limit and left limit are not equal, sir?
Sorry, why do you have to find function value? See,
Yes,
function
sir.
value is this thing. This is function value. Don't get confused. I'm finding the right limit. I'm finding the left limit separately. And I'm finding the function value. Because
Yes.
the reason I'm doing it is because the function, see, all the three functions are different. So I need to understand when I substitute the value of 0, any value less than 0, what am I going to get? If I substitute any value slightly greater than 0, what am I going to get? What will I get if I substitute exact 0 value?
No, sir. My doubt is if left limit and right limit are not equal already, sir, that means the point does not exist, right?
Function does not exist. But sometimes what will happen is left limit might match with the function value. Right limit might match with the function value. See, that time also it is not going to exist only. Even at that time it does not exist only. But I am doing an extra step of showing that the function value is also important.
Okay, sir. Understood.
Okay. See, sometimes what will happen, since you asked the doubt, I'm telling you, sometimes if the left limit matches with the function value, if this happens, right, then if I have to speak in terms of continuity, I'll call it as a left continuous function because it is continuous from left hand side. Sometimes if right limit will be equal to function value, but this will not be equal to left limit. Then what kind of function will this be?
Right continuous function, sir.
That's it. That's it.
So
It's
is
a
there
right
any case where left limit, right limit will be equal, but function value won't be equal, sir?
Yeah, there is a case. So yeah, there will be a scenario like that.
Okay,
So
sir.
for that, what will happen is the graph will be like this. From left hand side at x is equal to 0, let's say it is approaching towards 1. Right hand side also it will approach towards same, but they will not meet.
Stop before the point, sir.
They'll stop before the point, means that there will be an open circle like this.
Okay, sir. Understood.
So what is, so left limit is same, right limit is same, but function value doesn't exist. Okay, anyways, all these things you learn it on higher basis next year. So this year we are going to concentrate only on whether limit is existing or not. So I have not concluded this. They've asked, what is the value of A? What is the value or values of A for which the limit exists? So at x is equal to 0, does it exist?
Does not exist, sir.
Does not exist. So you can write for any real number other than 0, this function exists. Why I told any real number is because what is the domain of this function minus x plus 1? According to the question that is given, the domain of this function is minus infinity to 0. Correct? Because they have told x less than 0. X less than 0, the other way to write is minus infinity to 0. What is the domain of the function x greater than 1? Sorry, x minus 1. It is 0 to infinity. So if you look at the extreme values, the function is starting at minus infinity. It is ending at plus infinity. So minus infinity to plus infinity is another way to write real number. Right? So the meaning of this is minus x plus 1 is existing for every value between minus infinity to 0, except at 0. Similarly, x minus 1 is existing between any value from 0 to infinity except at 0. So for the total function which is defined from minus infinity to infinity, what is happening? It is not existing only at one point. What point is that? 0. So how we are supposed to conclude is for any real number except 0, this function is having its limit existing. Or you can say for any value of r except 0, the limit for this function exists. Can you check the answer and tell me how it is given?
X is for all values except a not equal to 0.
Except a not equal to 0 or
X is for all a not equal to 0 values, sir. X is for all a not equal to 0.
X is for all values of real number except for a not equal to 0. That's right. They have asked the value of a, no? A can be any real number except 0. That is what I'm trying to say. Or what they have actually given is a not equal to 0. They both mean the same. I hope you're able to understand. They both actually mean the same. Yeah. Okay. So there are two more problems left out. This we will see tomorrow. After this, we will start differentiation. So tomorrow's class, we'll start differentiation. It's simple. It's not very tough. So I suggest you all to practice this exercise. Just wait for a minute.